Hello and welcome to our screencast on model-based privacy and security analysis with CARiSMA. CARiSMA is an Eclipse-based tool which allows you to perform compliance, risk and security analysis on software models. Therefore, CARiSMA is based on the HumeLSec profile which has been proposed by Jan Jurjens. For more details on HumeLSec or for general details on CARiSMA, please refer to our tool's website. In this screencast, we are going to introduce a privacy extension for CARiSMA, as well as the integration of CARiSMA into the Vision Privacy Platform. The Vision Privacy Platform enables public institutions to evaluate and analyze privacy levels of public administration systems and has been developed in the Vision EU project. At first, tools collect citizens' preferences on privacy and security and make those available to other tools over a common database. These preferences are taken by the privacy requirement component to specify security and privacy requirements for the processes in the PA system. These requirements are taken by the privacy requirement component to analyze the system models of the public administration for security and privacy weaknesses. Our tool CARiSMA is included in this component. Therefore, CARiSMA reads from the common database the output of the STS tool, which is located in the privacy requirement component. This output is analyzed for relevant privacy and security requirements, which are presented to a developer for annotating the UML system models of the public administration with HumeLSec stereotypes. Furthermore, CARiSMA automatically generates an analysis configuration which can be used for analyzing the annotated UML models for relevant security and privacy properties. The analysis results of CARiSMA are shared with two other tools on the Vision platform. Let's have a look into the real tool. The workspace of our Eclipse instance contains the UML system models of the municipality of Athens, as well as the according STS tool output. We are going to show to you how we can read the STS tool output and automatically generate a CARiSMA analysis configuration, which we can use to verify the system model. In the first step, we create a pre-analysis configuration. In this configuration, we are selecting to create help document from the STS tool output. If we run this pre-analysis, we are asked if we want to load the STS tool output from a local file or from the Vision database. In this case, we are selecting to load the output from a local file. From the pre-analysis results, we can now generate a CARiSMA analysis configuration. This configuration contains recommended security and privacy related checks and analyses. In this case, the secure links check as well as the RABAC analysis is recommended. To perform these actions, we first have to annotate the UML models with the corresponding UML stereotypes from the security and privacy profiles. As an assistant, we can generate from the pre-analysis a report containing help content. This report contains mappings between UML model elements and STS model elements, as well as relevant security information for these elements. Let's have a closer look into one of these entries. For example, for the birth certificate, it's recommended to perform the RABAC analysis of CARiSMA. Relevant classes for this analysis are the max class and the system class in the system model. The system model contains the structure of the max system. Originally, we would now start annotating UML model, but instead loaded already the annotated model to show you the most important parts of it. In the first step of the RABAC analysis, we have to define the roles and rights. This is done with the RABAC stereotype on the class citizen registry. On this stereotype, roles and rights available in the system are modeled. The help report generated from the STS model recommended to specify access control for birth certificates. Birth certificates are issued by the issue birth certificate method of the max class. Therefore, we now are going to model access control on this method. We are requiring the right of modify to execute this operation. The modify right is in this system only given to employees. Furthermore, the status attribute has to be set to submitted. Possible attribute values are defined on the RABAC stereotype on the citizens registry. After modeling the security and privacy properties, we can now execute the generated analysis file. For the RBAC analysis, we first have to create another configuration. In this configuration, we specify which user and which state of the system we want to analyze. We are choosing an employee in the role of a citizen registry, and we are choosing that the status of the system is that the application form has been submitted. Now we can run the RBAC analysis, and we are choosing to also run the secure links check. In the results you can see that no violations of the secure links check have been detected. We can now generate a report for the RBAC analysis. In this analysis we can see that employees are able to issue birth certificates and grant discounts in the model scenario. If we would have chosen another attribute for the status, the issuing of birth certificates wouldn't be possible. Additional help content, an Eclipse update site containing our tool, as well as evaluation data, can be found on our tool's website. Also have a look on our institute's website or the website of the Vision EU project. Thank you for your attention, and please feel free to contact us if you have any open questions.